All right, starting chapter 7. Chapter 7 is all about exponential and logarithmic functions. So section 1 here, we're just exploring exponential functions and seeing what they look like. So you probably learned a little bit about exponential functions in Algebra 1. Exponential functions are in the form y equals a times b to the x power. Okay? Now we'll see a little bit more toward the end here exactly what these pieces do. So I'll leave a little bit of space here and then come back and add a couple things toward the end. But this is again our general form for exponential functions. Let's see what one of these looks like. Example 1. Let's graph y equals 3 to the x power. Okay. Now, this looks very similar to this general form for exponential functions right above. If you look though, what our a value really is, our a value, really there's a 1 that's in front here. That's just not written, okay? So let's start off by making a table of some values to figure out what this function is going to look like. And let's use a couple negative x values, a couple positives, and then 0 in there too. All right, so first of all, if I take -2 and plug it into my equation here, 3 to the -2nd power. Remember, negative exponents make this be 1 over 3 squared, which is 9. 3 to the -1st power would be 1 over 3 to the 1st power, which is 1/3. 3 to the 0 power, remember that anything to the 0 power is 1. 3 to the 1st power, and then 3 to the 2nd power is 9. Now if I plot my points here, I should use my graph stamp. Top y value up here is 9. So -2, 1/9. Hard to figure out where 1/9 is, but maybe just a little bit above the x-axis. -1, 1/3, a little bit more. 0, 1, 1, 3, and then 2, 9. Somewhere around here. Oops, probably a little too far over. There we go. Now we connect our points, and our exponential function looks something like this. Okay, now something to think about. Is our y value ever going to be 0? So can 3 to the x power ever equal 0? Oh, no. Because 3 to a positive power is going to be positive. 3 to a negative power, we'd have a fraction, and 3 to the 0 power is 1. So we will never have a negative y value with an exponential function, unless we had different transformations that happened. But without other transformations, without a reflection or a translation down, we can't have a negative y value. So that means our function is never crossing the x-axis. Okay, that leads us to probably a new word for you. So right here on this x-axis, trying to draw in the green here, we really have what is called an asymptote. And an asymptote means it's a line the function approaches. So on the end here, if you think of end behavior, okay, on the end here, this end is approaching this asymptote. It's approaching the x-axis, just never actually crossing. All right, So let's look and see a little bit more about what these values are and how they are changing. So I said that we're going to fill in a little bit more about what the A value is and what the B value is. If you look at our table, from 1/9 to 1/3 to 1 to 3 to 9, each time your Y value is tripling. And so this part in your exponential function is telling us it is our growth rate. It's your rate of change. Add that up here. B is the rate of change. Okay, and going along with that, we will have exponential growth if this B value is more than 1. And we'll have exponential decay where our function is decreasing if B is between 0 and 1. Okay, now B will have to be positive, B cannot be negative. So that's why I have the B is between 0 and 1 piece. Now what does A tell us? Okay, A in this problem was 1. We look and see where's 1 happening here. 1 is really your y-intercept. 1 is our y-intercept. It's your start value. It's your initial value or y-intercept. Okay, so that's the basics of exponential functions. We have this form y equals ab to the x. Growth if b is more than 1. Decay if b is between 0 and 1. And then we always are going to have, with exponential functions, we always have an asymptote, a line that this graph is going to approach, but isn't really going to cross, where our other end kind of takes off, keeps going up.